The winter of 2024-2025 will be remembered for its relentless, paralyzing cold across Europe and North America. For weeks, cities that usually see only a dusting of snow were blanketed in white, and temperatures plunged to record lows. Streets fell silent as people huddled indoors, and daily life ground to a halt under the weight of the cold. This wasn't just another cold snap. It was the result of a powerful event high above us, Sudden Stratospheric Warming, or SSW. While most of us felt the effects on the ground, the real drama was unfolding far overhead, in the upper layers of our atmosphere. SSW became the season's biggest weather story, a hidden force that unlocked the Arctic's freezer and sent frigid air south. Meteorologists watched in awe as the event unfolded, knowing it would shape the winter for millions. It all started about 30 miles up, where a rapid warming triggered a chain reaction that changed our winter. The stratosphere, usually calm and cold, suddenly heated up by dozens of degrees in just a few days, a rare and dramatic shift. The SSW event disrupted the polar vortex, a swirling mass of winds that usually keeps the coldest air trapped at the North Pole. This invisible barrier is like a spinning top, holding back the Arctic chill from the rest of the world. When the vortex weakened, Arctic air escaped, plunging normally mild regions into a deep freeze. Cities unaccustomed to such cold found themselves transformed overnight, with snowdrifts piling up and icy winds howling through the streets. In the next sections, we'll break down how the polar vortex works and why it's so crucial to our winter weather. We'll also look at how these upper atmosphere events can have ripple effects that reach all the way to the ground. We'll explore what happens during an SSW and why these sudden changes in the stratosphere can have such dramatic consequences for the weather we experience. And we'll see how these events led to chaos on the ground. From snow-buried UK towns, where daily routines were upended, to communities struggling to keep warm and safe, to record-breaking cold in North America, where even the hardiest cities faced challenges they hadn't seen in decades. This is the story of how a warming high in the sky led to a deep freeze below, a reminder that what happens above us can change everything we know about winter. Understanding this process reveals just how interconnected our planet's systems are. The atmosphere, the land, and even the oceans all play a part in shaping our weather. Let's explore how a stratospheric event became the defining force of winter, and what it means for the future of our changing climate. To understand the chaos of this winter, we need to look far above our heads, up to the stratosphere, a layer that sits between 6 and 30 miles above the Earth's surface. While we usually focus on the weather happening at ground level, the stratosphere is where some of the most dramatic changes begin, often hidden from our everyday view. A sudden stratospheric warming, or SSW, is a remarkable phenomenon where temperatures in this icy layer can skyrocket, sometimes by as much as 90 degrees Celsius, in just a matter of days. This rapid warming is so intense that it can completely transform the stratosphere's usual frigid state, creating a ripple effect that eventually reaches the surface. Unlike most warming events, SSW isn't triggered by sunlight. Instead, it's caused by powerful atmospheric waves, giant pulses of energy that travel upward from the lower atmosphere. When these waves crash into the stratosphere, they release their energy, causing temperatures to spike dramatically. This sudden burst of heat disrupts the polar stratosphere, which is typically cold, calm, and stable during the winter months. The balance that usually keeps the upper atmosphere in check is thrown off in a matter of days. The main victim of this disruption is the polar vortex, a vast, swirling mass of cold air that circles the Arctic. When SSW strikes, the vortex's stability is shattered, and its once tight circulation can become stretched, split, or even displaced. The normal west-to-east flow of air high above us can slow down, stop, or even reverse direction. This dramatic shift in wind patterns sets off a domino effect, sending shock waves through the atmosphere that eventually reach the ground. These changes don't reach us right away. It can take anywhere from several days to a few weeks for the disruption in the stratosphere to filter down through the layers of the atmosphere and finally alter our weather patterns at the surface. But this delay is actually helpful. It gives meteorologists a crucial window of opportunity to analyze data and forecast major cold outbreaks, allowing communities to prepare for sudden shifts in winter weather. SSW is a high-altitude event, but its impacts are felt all the way down to the ground. The chain reaction it sets off can influence weather patterns across entire continents, leading to extreme cold snaps or unexpected winter storms. In short, Sudden stratospheric warming is the first step in a complex chain of events that can turn an ordinary winter upside down, bringing dramatic and sometimes dangerous changes to our daily lives. The polar vortex is the engine of winter, a swirling mass of cold air and strong winds high above the Arctic. When strong, it keeps the cold locked up north, maintaining milder weather in Europe and the US. Think of it as a spinning top tight, fast and stable in midwinter, fencing off Arctic air. But it's not invincible. Powerful atmospheric waves can disturb it, making it wobble or even split. When the vortex weakens, the fence breaks, and cold air escapes south. This is what happened in winter 2024-2025. The vortex was hit hard, setting the stage for a deep freeze. The polar vortex's strength, or weakness, determines whether winter is mild or extreme. When it falters, the consequences are felt far beyond the Arctic. An SSW event is like a sledgehammer to the polar vortex, disrupting the delicate balance that usually keeps the Arctic's coldest air locked far to the north. This sudden stratospheric warming doesn't just nudge the vortex. It can shatter its stability in a matter of days, sending shockwaves through the entire atmosphere. The vortex's powerful winds weaken, and its once coherent shape becomes twisted and stretched. Instead of a tight spinning circle, the vortex wobbles, splits apart, and loses its grip on the polar air it once contained. This breakdown sends massive lobes of Arctic air surging southward, escaping the polar region and barreling toward lower latitudes. This isn't just a minor shift, it's a fundamental reorganization of the atmosphere, with consequences that ripple across continents. The jet stream below, usually a relatively straight river of wind, becomes wavy and erratic, twisting and turning in response to the chaos above. These new pathways allow frigid Arctic air to plunge deep into Europe and North America, reaching cities unaccustomed to such relentless cold. In late 2024 and early 2025, as winter tightened its grip, the effects became unmistakable. One lobe of the fractured vortex shifted over Siberia, while another settled over North America, each acting as a delivery system for bitter cold. The result? Arctic air was unleashed on millions, transforming daily life and straining infrastructure. The wavy jet stream meant these cold outbreaks didn't just come and go. They lingered, with freezing temperatures and snow lasting for days or even weeks. The result was a prolonged, punishing winter siege, with blizzards and deep freezes that tested communities across the northern hemisphere. The breakdown of the polar vortex's fence, the invisible barrier that usually keeps cold air contained, was the key to the season's extreme cold. This atmospheric domino effect started high above, in the stratosphere, but its consequences cascaded downward, shaping weather patterns for weeks. From bustling cities to remote villages, the impacts were felt everywhere, as the world was reminded of the power locked within the polar night. The deep freeze of 2024-2025 was set in motion by a single dramatic event in the stratosphere, proving just how interconnected our planet's atmosphere truly is. As the stratospheric disruption filtered down, Europe was hit head-on by Arctic air. A blocking high over the North Atlantic redirected Siberian air straight across the continent. The cold settled in, with temperatures far below average for weeks, straining infrastructure and daily life. When this frigid air met warmer seas, it picked up moisture, fueling heavy snow. On January 5, 2025, a major winter storm hit Western Europe, burying the UK and Germany in snow and ice. Severe weather warnings were issued, with some areas cut off by over a foot of snow. Black ice and freezing rain made travel treacherous, turning the festive season into a struggle for safety. The deep freeze was no longer a forecast, it was a harsh, disruptive reality. The severe weather brought Europe's transportation to a standstill. Major airports like Liverpool, Manchester, and Frankfurt closed runways, stranding thousands. Snow and ice overwhelmed even the most prepared crews, causing global travel chaos. On the ground, roads and railways were shut down, with black ice causing accidents and delays. Power outages hit cities like Birmingham and Cardiff, leaving many without heat. Flood warnings added to the crisis, as winter storms brought multiple hazards. Communities faced a multifaceted emergency, testing their resilience. The storm's impact was immediate and widespread, revealing the vulnerability of modern infrastructure. The deep freeze stretched resources and left a lasting mark on daily life. The same stratospheric disruption that froze Europe unleashed an Arctic blast across North America. A lobe of the weakened polar vortex sagged over the US and Canada, bringing temperatures 30–40 degrees below normal. Wind chills dropped to 20 to 40 degrees, creating life-threatening conditions. Cities like Minneapolis, Chicago, and Toronto closed schools and opened warming centers. Power grids strained, pipes froze, and travel was disrupted. This event showed how a single stratospheric shift can trigger simultaneous cold outbreaks across continents. The wavy jet stream guided Arctic air deep into North America, proving the stratosphere's power over our daily lives. The winter's deep freeze was a direct result of a high-altitude chain reaction. The Arctic blast didn't stop in the north. It plunged all the way to the U.S. Gulf Coast. Winter Storm Enzo brought rare, record-breaking snow to cities like Houston and New Orleans. For many, it was the first time seeing several inches of snow, an event not seen in decades. Roads became impassable, airports closed, and infrastructure struggled to cope. The southern snow was both beautiful and chaotic, highlighting the reach of the polar vortex's disruption. This rare event showed how a wobble in the stratosphere can send Arctic air on a journey to subtropical shores. The interconnectedness of our climate was on full display. Millions experienced firsthand how a high-altitude event can create winter memories far from the Arctic. The lesson: what happens above the pole can change life far below. The deep freeze of 2024–2025 was a powerful lesson in atmospheric science. SSW and the weakened polar vortex weren't just meteorological terms, they shaped daily life for millions. Understanding SSW is crucial, as it allows for earlier warnings and better preparation for extreme cold. The atmosphere's memory means this winter's disruption could influence next year's patterns. Early forecasts hint at another cold start for winter 2025–2026. By watching the stratosphere, we can better predict and prepare for what's ahead. The dramatic events of this winter were a reminder. The sky above is an engine that shapes our world. By paying attention to these invisible changes, we can navigate the winters of the future.